Okay, so now let us look at another couple of series examples, and all of them still asking us to check whether each series converges or diverges. Okay, so look at the first one. We have 5 over n minus 1 over n squared here. Okay, so for this example here, we can have we can think about into this way. First of all, if we combine those two into one, that's gonna be n squared is the denominator, 5n minus 1. Okay, 5 minus 1. And if we write into this, it looks like this series it gonna behaves very similar to this series from the long-term run. Okay, in other words, guys, think about this. If n is pretty large, this minus 1, we can actually omit it. Okay, so in other words, those two series, when n is extremely large, they behave very, very similar behavior. But look at what we have here. Now, this is actually 5 times this. Okay, this actually is a harmonic series. We know it diverges. Okay, it diverges. So from this observation, what we can tell? We can apply limit comparison test. Okay, limit comparison test. A limit comparison test, it says like this. We have two series, okay, here, and those both series, those are both positives. Okay, both positive here. So that's the only limitation for limit comparison test. And the limit comparison test said that if this limit, first of all, if it exists, okay, let's say equals capital L, and then the series A and B, they are both converge or both diverge. Okay, so in our problem here, this is our AN, this is our BN. Okay, and apparently, guys, as you can see, limit AN over BN in our problem, 5n minus 1 over n squared over this equals is n squared over 5n. So it turns out this limit equals 1. So my series Bn diverge since it's a harmonic, so I can get as a conclusion my original series also diverge. Okay, so diverge. Okay, so that's apply the limit comparison test. Now look at the other example here. So we have m plus 3, m plus 7 over n factorial. If a series involved with factorial, I highly suggest to use the ratio test, okay, because you can do a lot of cancellation for factorial. So let's do that. An plus 1 over an, absolute value. Since the term actually is positive, so I get that, so I have n plus 1 plus 3, n plus 1 plus 7 over n plus 1 factorial, right, over an, which is multiply the reciprocal of an, so it's n factorial over n plus 3 and n plus 7. Okay, So after the cancellation, you can see basically this n plus 1 factorial can be rewritten as n factorial times n plus 1. So it turns out this is what we have. We have n plus 8, n plus 4 on the top. We have n plus 1. We have n plus 3. We have n plus 7. Okay. So it turns out this, guys, think about this. You know, the order, if you multiply on the top, it's going to be n squared. The order on the denominator is going to be n cubed. So as n goes to infinity, this limit actually goes to 0. 0, of course, is less than 1. So based on ratio test, we know that this series actually converges. Okay? Not only converges, but also converges. Absolutely. Okay, absolutely. So that's a direct application about the ratio. Now, same thing for this one. You can see we have so many factorials. We can also apply ratio. So an plus 1 over an. That is 5n plus 1, n plus 1 factorial, n plus 1 factorial. I need to mention that this part is extremely important because often students make mistakes here. On the denominator is 2 parentheses n plus 1, and then there is a factorial. Okay. And then multiply the reciprocal, so it's 2n factorial, 5n, n factorial, n factorial. So, you know, there are a lot of cancellation get involved here. So you have 5 left. On the top, you have n plus 1 left. There's another n plus 1 left because n plus 1 factorial can be written as n factorial times n plus 1. Okay. And also, I need to make sure that this part is going to be 2n plus 2 factorial. Okay. So it's 2n plus 2 factorial. It's going to be 2n factorial times 2n plus 1, and then times 2n plus 2. Okay. So after that cancellation, we have 2n plus 1 and then 2n plus 2. Okay. Now, turns out that, guys, this series, if you only look at the leading order, as n goes to infinity, you're going to have it's a 5n squared over 4n squared. Okay. And then we know, right, because if we simplify that, so the limit for this actually going to give us is 5 over 4. And this number actually is greater than 1, right? So based on the ratio test, we know that my series actually it diverges. Okay? So those are the 3 examples. One example using the limit comparison test, and then the other 2 uses these ratio test. Okay, so hope you enjoy this video, and thank you for the watching.